Traditional penetration testing finds what is already broken. You simulate an attack, discover an exposed vulnerability, and patch it. It is an inherently reactive process. Contrast that with threat modeling. This is the proactive discipline of identifying architectural failure points before deployment, finding what could break before the infrastructure even exists. In a cloud environment, reactive security is often insufficient. When new services are provisioned in minutes and infrastructure as code changes weekly, waiting for a penetration test means you are already behind the current state of the environment. To achieve a robust cloud defense posture, you have to reconcile two distinct security frameworks. The first is the STRIDE framework. This classifies the theoretical what, the fundamental security property an attacker is attempting to violate. The second is the MITRE ATT&CK for cloud matrix. This classifies the operational how, the specific techniques and API calls attackers actually execute. Without both the theoretical property mapping and the operational API telemetry, security teams struggle to scale threat detection in rapidly mutating cloud environments. This table outlines the STRIDE model. Developed by Microsoft, it is a structured classification system covering 6 primary attacker goals. The S stands for spoofing, which is the impersonation of an identity. In the cloud, stealing JWT tokens to call APIs as another user directly violates the property of authentication. The T is tampering, unauthorized data modification. Writing malicious files to an S3 bucket violates the system's integrity. R is repudiation. This occurs when a user denies performing an action, like disabling CloudTrail logging right before exfiltrating data. This breaks the property of non-repudiation. I is information disclosure, or unauthorized access. Leaving an S3 bucket with sensitive data publicly accessible is a failure of confidentiality. D is denial of service, preventing legitimate access. An EDOS, or economic denial of service attack, that deliberately consumes auto-scaled compute violates availability. Finally, E is elevation of privilege. Gaining higher access than granted, such as exploiting an IAM PassRole permission, breaks authorization. Classifying threats through STRIDE creates a systematic checklist to ensure that every fundamental security property is addressed when designing a cloud architecture. Let's apply this to a standard multi-tier AWS web application to serve as our baseline architecture. Traffic flows from EC2 instances through an application load balancer to a Lambda function, backending into RDS and S3. Starting at the perimeter with spoofing threats, we isolate the risk of fake SSL certificates on the ALB hostname or JWT token theft via cross-site scripting on the web front end. The operational mitigations include using auto-renewing ACM certificates, enforcing HTTP-only cookies, and requiring strict MFA policies. Moving inward to tampering threats at the logic and storage layers, we identify the risk of SQL injection passing through the Lambda function to modify RDS data, or an attacker replacing application assets within S3. We mitigate these by enforcing parameterized queries in the Lambda function, alongside S3 versioning and object lock. Next are repudiation threats against the management plane. The primary risk is an attacker disabling CloudTrail logging immediately before data exfiltration to cover their tracks. To counter this, you enforce CloudTrail log file integrity validation and place an S3 object lock on the centralized log bucket. Applying STRIDE systematically to an architecture graph transforms abstract vulnerabilities into localized engineering tasks. Continuing through the architecture, information disclosure threats include accidental public S3 bucket policies, or API keys exposed in CloudWatch because they were stored as Lambda environment variables. The fixes are implementing S3 block public access at the account level and utilizing AWS Secrets Manager instead of environment variables. For denial of service threats, we map the risk of the ALB being flooded with requests that deliberately exceed Lambda concurrency limits. We mitigate this by deploying AWS WAF rate limiting, configuring Lambda reserved concurrency, and utilizing Shield Advanced. Finally, elevation of privilege threats stem from IAM misconfigurations. An overprivileged EC2 instance or a Lambda execution role with a wildcard IAM PassRole permission allows an attacker to pass any role to any service. The defenses require strictly adhering to least privilege IAM, conducting regular access reviews, and implementing IAM Access Analyzer. STRIDE maps the theoretical mitigations required for this architecture. However, it lacks the operational telemetry to catch an attacker bypassing these controls. This matrix is MITRE ATT&CK for cloud. It serves as the operational counterpart to Stride, shifting our focus from theoretical properties to concrete API telemetry. It maps out specific tactics and exactly where to detect them. For initial access using valid accounts, technique T1078, detection relies on identifying anomalous GetCallerIdentity calls from unfamiliar source IPs. Execution via serverless execution, T1648, occurs through malicious Lambda functions. You detect this by monitoring function invocations from new or unusual principals. Persistence through account manipulation, T1098, requires tracking CloudTrail for unauthorized CreateUser and CreateAccessKey events. Privilege escalation via valid accounts is detected by isolating anomalous assume role API calls, attempting to access sensitive administrative roles. Defense evasion via impaired defenses, T1562, yields signals like AWS config rule violations or a CloudTrail StopLogging event. For credential access through unsecured credentials, T1552, defenders look for EC2 instance metadata service abuse, detectable by monitoring access to 169.254.169.254 within VPC Flow Logs. Discovery via Cloud Service Discovery, T1526, involves attackers enumerating S3 or EC2, generating high-volume list and describe API calls, and exfiltration via transfer data to cloud account, T1537, has a detection trigger, the execution of a put bucket replication call on sensitive buckets. By hunting for these specific API telemetry markers, security engineers can detect active operational behaviors, regardless of which architectural component is targeted. Analyzing cloud security through a single lens leaves significant blind spots in the defense posture. The Stride model dictates the what, identifying exactly which foundational security property an attacker is attempting to compromise. MITRE ATT provides the how, translating those theoretical threats into observable operational API techniques. Relying solely on mitigation theory invites compromise when a control is bypassed. Relying solely on telemetry alerts creates alert fatigue without the architectural context needed to prioritize them. Ultimately, synthesizing Stride and MITRE ATT provides a scalable detection engineering toolkit for defending modern, high-velocity cloud environments.